My name is Sarah C., and I'm going to be taking you through the process of implicit differentiation. For our first problem, we have x squared plus y squared is equal to 16. Find dy over dx. For our first step, we are going to derive both sides of the equation in terms of x. X squared derives to 2x, and in chain rule we must derive the inside of the function as well, so that we also multiply by dx over dx, which simplifies to 1. The derivative of y squared is 2y, and we must also derive the inside of the function so that 2y is multiplied by dy over dx because we are deriving in terms of x. Anytime we derive a number value, it turns to 0, so that in this case 16 turns to 0. Now we need to isolate the dy over dx term, so we subtract 2x to the other side of the equation and then divide 2y to the other side of the equation as well. Our final result is dy over dx is equal to negative 2x over 2y. Hi all! Just before we get into some longer problems, I wanted to let you know about some common mistakes which are done in implicit differentiation. In implicit differentiation, most often, people will forget to differentiate each and every term in the equation. For example, in the problem below, ln xy is equal to 4x, most people will jump right into deriving the term xy without first looking at the ln in front of the equation, so that their beginning steps will lead to 1 over y plus x dy over dx. This is wrong. To do this equation correctly, first we must look at ln xy. The derivative of ln xy is 1 over xy. Then we will do chain rule so that we multiply the equation by y plus x dy over dx, and this will be equal to 4. Then we simplify to y plus x dy over dx is equal to 4xy. We isolate the dy over dx term and we get x times dy over dx is equal to 4xy minus y. We finally get dy over dx is equal to 4xy minus y all over x. In equation number 2, use implicit differentiation to find the slope of the tangent line to the curve at the specified point. 2 times x squared plus y squared squared is equal to 25 times x squared minus y squared at point 3, 1. First, we take the derivative of both sides of the equation. This means that we do chain rule on each and every term in the equation. We get 4 times x squared plus y squared times 2x plus 2y dy over dx is equal to 50x minus 50y dy over dx. Rather than try and solve for dy over dx now, we can just go ahead and plug in x is equal to 3, y is equal to 1, and solve for dy over dx with numbers, which is much easier. We get 4 times 3 squared plus 1 squared times 2 times 3 plus 2 times 1 dy over dx is equal to 50 times 3 minus 50 times 1 dy over dx. This simplifies to 40 times 6 plus 2 dy over dx is equal to 150 minus 50 dy over dx. We subtract 240 on both sides of the equation. This gives us 130 dy over dx is equal to negative 90. We divide both sides of the equation by 130. This gives us dy over dx is equal to negative 90 over 130, which simplifies to dy over dx is equal to negative 9 over 13. In equation number 3, we are asked to differentiate cosine squared x plus cosine squared y is equal to cosine 2x plus 2y. We do this equation by using chain rule. We also derive every part of the equation by doing this. So we have the derivative of cosine squared x plus the derivative of cosine squared y equal to the derivative of cosine 2x plus 2y. We get 2 cosine x times the derivative of cosine x plus 2 cosine y times the derivative of cosine y is equal to negative sine 2x plus 2y times the derivative of 2x plus 2y. We get 2 cosine x times negative sine x plus 2 cosine y times negative sine y prime is equal to negative sine 2x plus 2y times 2 plus 2y prime. We simplify to negative 2 cosine x sine x minus 2y prime cosine y sine y is equal to negative 2 sine 2x plus 2y minus 2y prime sine 2x plus 2y. We simplify to 2y prime sine 2x plus 2y minus 2y prime cosine y sine y is equal to negative 2 sine 2x plus 2y plus 2 cosine x sine x. Now we can isolate y prime on one side of the equation by factoring out, resulting in y prime times the whole of 2 sine times 2x plus 2y minus 2 cosine y sine y is equal to 2 cosine x sine x minus 2 sine times 2x plus 2y. We have y prime equal to negative cosine x sine x minus 2 sine times 2x plus 2y over 2 sine times 2x plus 2y minus 2 cosine y sine y. We factor out anything we can find out of the equation, resulting in y prime is equal to 2 times cosine x sine x minus sine 2x plus 2y all over 2 sine 2x plus 2y minus cosine y sine y. Finally, we get the answer as y prime is equal to cosine x sine x minus sine 2x plus 2y all over sine 2x plus 2y minus cosine y sine y.